Arrays are a type of construct, something else we're going to declare. It's a type of variable. All the variables that we've used so far, the variable types, have been what we call simple data types. We have integer, we have float, we have char, we have Boolean. These are for a single entity, okay? Arrays are what we call a composite data type, meaning they allow us to declare groups of things. Okay, so let's talk first about why we need arrays. So on the sheet that I've given you, no, you can go back. On the sheet that I've given you, the very first problem that I want everybody to do is I want you to write a program, a couple lines of code that inputs 3 test scores and computes the average. So on problem number 1, just write the solution for 3 test scores, declare 3 test scores and compute the average. And I want, in the spirit of what we did yesterday, which I thought worked kind of well, I want somebody to come up and do that for me here. Okay? So we're all doing problem number 1 on the exercise sheet. And I'd like a volunteer / somebody I call on to come up and do the first problem. These will get harder, so again, the advice is do something you think you know the answer to, because the problems are going to get harder. Okay, so Tyler's going to do this first one. He's no dummy. So this is nothing new. We're going to take 3 test scores and compute the average, and we can all do that, right? We should all be able to do that at this point in time. Just declare 3 test scores and compute the average. So everybody should be doing this, just declaring 3 test scores and computing the average of those 3 test scores, which is pretty easy, right? Declare the 4 variables, 3 of which are test scores, and 1 of which is the average. Don't look at him. Do it yourself. Come on. Why are you copying? Everybody should know how to do this. Declare 3 test scores, input them, and compute the average. The only thing that I would say is that we've been advised by, for security reasons, to not put 3 on one line. So if you could put score 1, if you could declare score 1, it's a recommendation for secure coding to declare each variable per line. Sometimes I do it too. So some of my examples, I keep trying to get them. Well, the problem is with initialization. So if I did what he did and I initialized the last one, only the last one would get initialized, and you may think you're initializing all 3. So it's really more, it's not really something somebody could hack. It's more of a problem just in the robustness of the code. Okay? So again, if he had done score 1, comma, score 2, comma, score 3, and said equals 0, only the last one, and you might have thought you were doing all 3. So it's just, that avoids that false sense of security, essentially. Okay? An easy thing for us to do, so I always teach students to do it. Okay, so in this case, it's pretty easy to input 3 test scores and to compute the average, okay? And everybody has the same thing, right? Awesome. Okay, so then the next problem, so this is for a defined 3 test scores. The next problem allows, I want you to, if you look at number 2, I'd like you to write the code that allows you to input as many test scores as the user wants using the sentinel value of -1. So you're going to need a loop. Input test scores until -1 and compute the average this time. So write the code for number 2. This time, you only will need 1 test score variable. And you're going to do the steps necessary in order to compute the average. Grab them. All right, so we're going to do number 2. So we need a loop. We need a sentinel loop. So hopefully everybody feels comfortable setting up a sentinel loop, right? Raise your hand if you need help, if you want me to look at it. So start with the loop condition. Let's put problem number 2 on the board. I think it's below. Is it below here? Do I have it in the compiler yet? Yeah. So we're doing problem number 2, and I'm looking for a volunteer to do this one. Looking for a volunteer to do problem number 2, okay? Yeah, me's going to do this one. So this time we use one test score, and we need to do what in order to compute the average? Make a total, and what else besides a total in order to compute the average? A count. So he's going to add the steps to do a total and a count. He's going to read the test scores in. He's going to sum them all up. He's going to count them, and then compute the average after they've entered the -1. I just think you need to indent everything. So this is his start step. Why don't you tab that guy too? So a lot of you probably started with while test score is not equal to -1. Does everybody feel comfortable with this now, hopefully? Okay. And then he's going to add the accumulator and the counter into the action steps. This should be pretty automatic to you by now, right? Every time you want to compute an average, you're going to, okay, what does he need before this? Since he's got multiple steps. Bracket. Okay, so now he's going to do a counter, which the 2 steps, you want to pick up a handout? The 2 steps for the counter are count plus plus, and then he would have to initialize it up top, and then he needs a total. Okay, so put a semicolon here. And then don't forget to initialize the counter to 0 up front. It's fine, you're being brave. So put the counter up top before the loop and set it to 0, right? Sometimes I even do that when I declare it, yeah. What type should the counter be? What type should the counter be? Why? It does matter for counter. For counter, because when you count things, what type of number is that? The whole number, right? Does that make sense? Okay. All right. So the counter should be a whole number, okay? And he's going to set that to 0, and then the total. If test score is float, then the total should be a float. And then he's just going to read the. He's going to put the accumulator next. So it's going to be total equals what? Remember? Exactly. So he adds each test score to the totals. This all makes sense, okay? And then he's going to ask for the test score again. You can stand to fix up the indenting a little bit, but just do your restart step again. Not so easy, is it? It's hard typing up in front of everybody. And then he needs to implement, he has to do that. So yeah, he'll have to declare total and set total equal to 0, yeah. Yep. Could you initialize it in the declaration? Yes. Yes. And then he's going to compute the average after the loop, because you don't really, generally, unless the program specifically asks for a running average, you don't do the average till you're all done. So the average calculation goes here. And we all know how to compute an average. And what test should he add to this? What test should you add to this? What happens if they enter -1 as the very first test score? And it'll quit, and count at that time will be 0. So it'll divide by 0. So you need to add a test here if count is not equal to, right? Does that make sense? Okay? Which is why I love this problem so much, because you have to remember all these things. Okay? So we have to check for divide by 0. Question on that? Does that make sense? Why we do all this? This is all review right now. Okay? And then he would print the average, and we've got the logic there. So thank you for doing that. Okay? So then the question number 3 is, can I print the test scores that were entered in problem number 2? No, what happened to them? I got written, all I have is the last test score, the -1, actually. So I didn't store the test scores, right? So if I have 5 test scores and I want to compute the average, okay. I make test score 1, test score 2, test score 3, test score 5, test score 4, 5. But if I have 100, that's not going to work, right? So what if, which is the case in many situations, I want to be able to store 1,000 test scores and I want to be able to access them. I don't want a different variable for each one. Does that make sense? Okay? So we want to have the ability to store the test scores. If I now, thanks, perfect. If I wanted to find the highest test score, I'd have to change the code. I don't have the test scores. They've all been entered. They're gone. All right? So I'd like the ability to store the test scores and be able to do a bunch of things to them, not all as I'm reading them in. Okay? And if you look at question 3, 4, and 5, basically we cannot answer 3, 4, and 5 with what we have now. So I'm going to show you a way to create an array. Okay? So an array is the first structured data type that we use. And there's a couple of terms we're going to use here. Array is the variables. There's no keyword in C++ that's called array. We're going to actually use square brackets to give a size of an array. So there's no keyword that says array. So we're going to declare an array, and the array is going to be made up of 2 things. The array is going to be made up of elements or members of the array, and we're going to use something called an index to determine which element of the array that we're accessing. So these are the terms we're going to use: array, element, and index. And none of these are keywords in C++. Okay? So the format is the following: type, which we know what a type is, what our types are: int, float, char, bool, string. Okay? A name, which we're going to give to the array, and then we're going to use square brackets, and we're going to specify a size. And this is going to allocate space and memory for the array. Notice the word array never appears here. Okay? So I only have to do this once. Now, something to remember about the size, and this is true in C++, the size must be a constant. What do I mean when I say the size must be a constant? Give me an example of a constant. A fixed number, such as 100, right? Or what's the other way of doing a constant? Declare a constant. But it can't be a variable. Either a set number, like 100 or 1,000, okay? Or a constant that I've already declared. I cannot make a variable, an array of a variable size. Because when the array is declared, the same thing that happens when a variable is declared. What happens when a variable is declared? Space is allocated in memory. When an array is declared, space is allocated in memory. So the size must be known. Does that make sense? Okay? I'll go over this again. So here's an example of declaring an array of test scores and allocating space for how many of them? 30. So float test scores sub 30 means in memory, space will be allocated for 30 of those suckers. Okay? So that statement allocates space for all the guys. I could have made a constant and then replaced, whatever. It doesn't have to be a 30 there. I could use it. That's oftentimes done when you declare arrays. So therefore, if you want to change it later, you can change it in that one location. But the bottom line is whatever's in those brackets, those square brackets, must be a known value. It can't be an X or a variable. Okay? Okay, so that's easy, right? So we can declare an array called days of type float with 365 of the suckers. We can declare an array called code, which has 12 characters in it. We can declare an array called buff, which has 100 integers. What do these guys look like in memory? Okay? So if I declare an array called test scores, type, name, size, that's all you have to remember, type, name, size. What takes place in memory is 10 of these guys are allocated. Each one of these guys is called a member or element of the array. Now, notice that what we've done, though, that we're going to use a number to access each element of the array. And we're going to call that an index or a subscript. Either one, they're interchangeable. Okay? So since I've allocated space for 10, what do you notice about the highest subscript that I can go to? And why is that? Why is it 9? Because I start with 0, that means that 10 elements is 0 through 9. And welcome to coding. Coding is almost always 0-based. Bless you. Coding is almost always 0-based. So this is a 0-based array. The first index is 0, and the last one is 9. That doesn't mean you give 9 as your size. Your size is still 10. Okay, does that make sense? Your size is still 10. So 10 elements means elements from 0 to 9. You with me? Okay, cool. So let's then, a number 6, declare an array that will have space for 100 test scores. And if you look at the bold, number 6, page 1 still. Did I say page 6? Okay, so if you look at the bold, that'll tell you the format to declare an array. The first thing you're going to do is give it the type. And whatever you've been using for test scores, you're going, bless you, I know we're all sick. Whatever you've been using for test scores, that's going to be your type. Your name is going to be whatever, and your size is going to be 100. So for number 6, go ahead and allocate space for 100 test scores using type, name, size. Number 6, go ahead and fill out number 6. Allocate space for 100 test scores. Number 6, allocate space for 100 test scores. Yep, you sure can. So this gets declared wherever your variables usually get declared. If it's declared inside a function, what is the scope of that array? If I declare an array inside a function, what is the scope of that array? Local to that function. If I mistakenly declare an array up before main, what is the scope of that array? Global. Okay, so same rule. Okay? So, okay, and then what do you need at the end of it? Yep. Semicolon. So this allocates space for 100 test scores. Everybody with me? Good. Okay? So far, so good. This is how I create these arrays. Now, if you look at the sheet and turn your page, just for the sake of brevity, I have done it for a 10-element array because I didn't want to draw a picture. But I want everybody to look again at this picture. If I declare an array of 10 integer test scores, what's allocated in space is 10 memory locations, 10 memory locations. And I could access the memory locations by using the name test scores sub 0. So if I said test score sub 0 equals 100 equals 95, what would happen if I said test score sub 0 equals 95? The value 95 would get stored, and we'll get to that more later, okay? So keep that in mind, and then let's fill out the rest of the sheet declaring arrays. So page 2, let's declare all these arrays. Go ahead and declare all these arrays on page 2. Type, name, size. Type, name, size. Volunteers to do number 3. Okay. No, we'll spread out the will. Enough people will wake everybody up. Okay, but it says, what does it say? What kind of temperatures are they? Okay, number 4. Okay. So right, so yeah. Oh, you want to do 6? Yep. So you see how to do this. So far, so good. Declaring the array. All we're doing new. Thank you. Now, the only thing I might give this a plural. But it's going to be name sub 0. I mean, I don't know. I tend when I give an array name to give it a plural. I can be talked out of it. Hold that, right, okay. But I typically, I don't know, do you do the same thing? When I give an array name, I typically, you want to go ahead and do the next one? I typically make it a plural. That's just my convention. I'm not saying, I can see this both sides. It's just something I always do to kind of see the difference between one name and multiple. Okay, who wants to do 6? Okay. Who wants to do 7? Okay. We've learned so much. I'm so sad. Okay, 7. Can you move the screen down a little bit, please? Yep. Seven. Just go to the end of 7 and do a return. Okay, now, you picked a hard one. So, yeah, why do we choose string for zip code? You remember that? Can somebody explain why we choose string for zip codes? Anything we don't do mathematical on, we typically use string. And there's a couple reasons for that. Remember? We said if it begins with a 0, there are zip codes that begin with 0. Do you remember that vaguely? IDs, we use 0. Phone numbers, we use strings. Remember that? Yeah. Go ahead, you want to do the next one? Yep. Does everybody remember that when we talked about IDs and social security numbers and zip codes, it's computer science convention to choose string, okay? You picked a hard one. Okay, and then the next one's a tiny bit tricky. Okay, good. Can you scroll up? Who's going to do 9? Not that tricky. Okay, let's give everybody. Who else hasn't gone? All right, Nikki, you want to do 9? And then 10. David's going to do. I'm not trying to put anybody on the spot. Just makes people pay attention more. Okay, David's going to do 10. Okay, so you get the idea of declaring arrays. Woohoo. Now we need to do something with them, right? Now we need to do something with them. Okay. So he's finishing 10. Good. Okay. So the next thing we need to be able to do is we need to be able to do something to the individual elements of the array. So the way that I do that is I use the name of the array followed by a subscript. So if I declare an array called buff and it has 100 elements, then it's clear to everybody that buff sub 0 is the first and buff sub 99 is the last. Now before I'm going to talk about this a couple times, one of the big and oldest security vulnerabilities in programming is the buffer overflow. This is an old security problem, and guess what? It's still there. It is so easy to write beyond the end of an array, and C++ is terrible at checking for it. It lets you do it. So if you have space for 100 and you try to write to 102, guess what it does? Writes right over memory whatever's there. Okay? Doesn't give you an error, doesn't, necessarily crash. It writes right over memory. And this is called a buffer overflow. This is one of the most exploited and oldest security vulnerabilities that exists. Now, Java is safer in the sense that it throws an out-of-bounds exception if you do that. Well, I still don't think that's a good thing, right? But at least it doesn't let you write over memory. So buffer bounds are a big place for hackers to exploit, okay? So C is terrible because it doesn't check at all. All right, so let's keep that in mind. We're going to do a security injection on that. Let's talk about what we can use as a subscript. So if you look here, I can have a number. So if I have an array I can have a variable, an expression, or a number, constant, okay? So angle sub 0 equals 493. I'm using this just like a variable. So I can access elements of the array. If I have 20 test scores, I can say test score sub 3 equals 95, just like I would X or Y or anything else, okay? But notice that I can use numbers as my subscripts, and I can also use variables. So without knowing the details of the array, can you tell me what this third bullet is doing? What is this third bullet doing? Not two arrays. 2 elements. And what is the deal with those elements? Can anybody expound on that? What is special about those elements, and where is the sum going? Can you look at that problem and tell me what's happening when you have val I and val I plus 1? Who's trying? Go ahead. It's adding this element. If this is val sub I don't care where it is. Where's val sub I plus 1? The subsequent element, right? It's taking this element, adding the subsequent, and it's putting the sum where? In the one below. right? I don't even need to know what I is to know that it's adding subsequent elements and putting the sum in the one below. So this is an example just showing you that I can use a variable, which is going to be really useful in a little bit, you're going to see, and I can use expressions inside the subscript, okay? Now, what is this guy doing? What is C out score sub k, k plus 1, score k plus 2 doing? What's that? In a similar fashion, what is that doing? But if this is score k, where's score k plus 1? The one immediately following. So it's outputting 3 subsequent test scores. K plus 1. Okay. So we can do anything to an array element that we can do to a variable. I can assign to an array element. This is important. Okay, this is our next exercise. I can assign a value to an array element. I can put it inside an expression. I can output an array element, not a whole array, an array element. I can check to see if an array element is some value. I can input an array element so long as I give, and how do I access an array element there? What's the deal then? Name of the array followed by the location within the array. Does that make sense? The index. This is called the index. You with me? Okay, so let's try it. So if we look at page 3, I've done the first 2 examples for you. So this is using the same arrays we declared in the previous exercise. So in number 1, in the previous exercise, I declared an array of weights. So if I want to assign 45.5 to the first element, does everybody see why it's weights sub 0 equals 45.5? Does everybody see that? Okay. If I want to assign, if I have an array called K, and it has 20 elements, and I ask you to assign X to the last element, does everybody see in number 2, K sub 19 equals X? Okay, so what I'm going to do is I'm going to put up the previous arrays, and I want you to do the steps that are, so here's the arrays that we declared. So we've already done weights and K. So for number 3, you're going to output the second element of the I call it temps array. So go ahead and write the code for outputting the second element of the temps. How can I do this? Maybe I need to get rid of all these. All right, so go ahead and finish that. I'll bring everybody up. This is page 3. We're doing number 3. See if you can figure out the steps for each one of these. Okay, so who would like to do number 3? See out the second. Okay, Matthew's going to do that. Okay. So does everybody get a feel here? So you've declared the array in the previous step. Now we're accessing an individual element of the array doing something specific to it. So we're going to take the second element of the temps array, which the first element is what? Temp sub 0. So the second element is temp sub 1. So if it asks to out perfect, C out the second element of the temps array, it's C out temp sub 1. Everybody with me? Okay, so who would like to do number 4? Okay, Claudia? Okay, good. Any questions about that one? The fifth element is the element sub 4. Who would like to do number 5? The flags array. Kelvin, you want to do number 5? 4, 5, 5, 5. And then we're going to start to get a little trickier. Some of them are tricky. I think 6 is a little trickier. The tricky part, in my opinion, with arrays is the syntax. The actual concept is not difficult. The syntax gets tricky. Okay, so now we're not C-outing it. We're setting it to true, right? So flags, which one's the fourth one? Right? No CN either. Just flag sub 3 equals, right? Get rid of the CN and the C out. Okay? So flag sub 3 equals okay, yeah, that worked. I wasn't sure if you had to do uppercase. Semicolon. You had a semicolon? Okay? Right? That's a Boolean array. So to get the fourth guy, that only is going to accept Boolean values. Does that make sense? Okay, the next one's a little tricky. We're going to take the 7th test score in the test scores array, and we're going to add 1 to it. Who thinks they can do number 6? Who thinks they can do number 6? Ryan? You want to try number 6? So we're taking the 7th test score, two ways of doing this. There's 2 ways of doing this. Yes, that's one way. Does everybody see the syntax here? Don't mess with the 6. If you put the 1, if he had put the 1 in here, he would have changed the semicolon. That's good. Can you think of one other way to do it? Can anybody help him? What? Yeah, can you try test score 6 plus plus? You want to try that one? Just below it, yeah. There's actually 3 ways, but I don't think most of you know this. Okay, so now where does the plus plus go? Again, the syntax is right outside, exactly. It doesn't matter if it's before or after. It's plus plus right there. Make sense? So just like a variable, good. Okay, that was a tricky one. So the syntax is the question here. Does this make sense? Now what would have happened if he just did this? Test score sub 6 plus 1. Why would that have been wrong? You're not putting it anywhere. You're not putting the answer anywhere. So it's necessary to do the whole thing. Okay, who would like to do number 7? Okay? Perfect. How about number 8? Jamera, you want to try number 8? Oh, somebody has their hand up? Oh, no. Jamera, you okay to do it? No? Who wants to do it? Okay, Allison? So how many did song titles have in it? 1,000. Okay, good. All right, number 9. Who wants to try number 9? Abel, you want to try number 9? A little bit trickier, but not hard. You need 2 statements to do this. Okay, that's the second guy, right? Okay, so nope. If it's what type was test answer? What type did we use for test answer? Care. So what would you put instead of true? The T in single quotes, right? Right? Does that make sense? We did. Go up. Go up. You use both. Okay, we use care, I think. So if we use care, put a single quote T. Okay, and then now that's the second guy in the array. So what's the first guy in the array? But which one should you do it to this time? Yes, exactly. Make sense, everybody? So there's a lot of things going on here. You have to know the type. You have to know assign a T to it. If it was Boolean, he would have been right. But we chose character for this one. Question? No, cannot do that. But that's actually going to lead to the good thing. How are we going to work on the whole array, right? I'm going to show you that, okay? So then the last guy I think I can do, class name, sub. How many do we have in class name? 100, so 99 equals computer science. In that case, what would I use? I wouldn't use single quotes. I would use double quotes because it's string. So you see how everything builds in this class? We have to know the types, all that stuff, okay? Everybody with me? Now, this is all just peachy keen, but how would let's go back to my first question that we had at the very beginning of class, which was, how do I print all the test scores? How do I find the highest? How do I input 100 test scores? So, guess what? There's a way. But I cannot do this. I cannot say array equals 0. I can't go into the code and say int array 100 and then array equals 0. I cannot do pretty much anything to the array as a whole. It just doesn't work. It's not allowed. These are invalid operations. I cannot see out an entire array at once. Cannot do it. Does everybody see that? I cannot do it. It's illegal in C++. I can see out scores sub 0, and I can see out scores sub 99, but I cannot say see out scores. Error. Okay? I also cannot see in an entire array in one fell swoop. I cannot assign 2 arrays to each other. So what the heck how the heck am I going to do with this stuff? How am I going to input 100 test scores? How am I going to sum 100 test scores? How am I going to output 100 test scores? So does anybody have any ideas? So let's say that I come to my compiler and all this stuff, blah, blah, blah. It's all going to go away. And let's go back to my original test scores, which was float test scores sub 100. Can somebody tell me how I can set every one of these test scores to be 0? I certainly don't want to do this. Because how many times do I have to go test score sub 0 is 0, test score sub 1. That's the whole reason I did the arrays, was to avoid this. Ideas. I can use my friend the for loop. And I'm going to start, we're not quite there yet, hold on. So we're going to start the array at what? I mean the index at what? And I'm going to I could do that, but I like this better. Because I don't want to add a new number to the equation. If there's 100 elements, let's go to less than 100. Won't that go to 0 to 99? Isn't that cleaner? The other guy works. This is cleaner. And what is this step going to be? And there you have it. 2 lines of code. I just did everything to the array. I took my friend the for loop. Is that sarcastic? Is he not our friend? I brought our friend the for loop to do the work for me. So regardless of the size of the array, I can now use the for loop to do all the operations on the array in basically a couple lines of code. Are you with me? So let's go to the next exercise, which is all going to work on this array. No. Here we go. All going to work on this array that I created. And I want you to write the code. So we're going to use a small array just so I can show you. I'm going to run these and actually show you. I want you to write the code to set that whole sucker to 0, print that whole sucker, input all those guys, blah, blah, blah. So we're on page 3, or 4, is it 4? 4, and now we're going to answer the question that we started the class off with, how to do that. Okay, so go ahead. Go ahead and write the code given that array to use for loops to do all the things I'm asking you to do. And we'll fill it in on the board just like we did, so get ready to volunteer for the ones that you think you know the answers to. Oh, okay. Just grab them all. Okay, all right. So who would like to do number 1? Number 1 and number 2 is what we're looking for. Volunteers for number 1 and number 2. Who hasn't gone? These are the easy ones. I suggest you. My victim is. Kalia, would you like to try number 1? Thank you. Everybody doing okay with these? What's that? Okay, so here's my piece of advice if you're confused. Write the code to do it to the first guy. So if I said to you, set the first test score to 0, what code would you write? Write it down. Everybody knows how to do it. If I said set the first test score to 0, how would you do it? You would say what? What would you say, Jake? Test score, if I said set the first guy, you've got that array, test, don't look. So I've got test score sub 10. If I said set the first guy to 0, what would you do? What's the first guy? Which one's the first guy? Test score sub 0 equals 0. That's it. Change that guy change 0 to an I, pop it into a for loop. That will do all of them. That's it. So if you think how to do the first one in your head, and then change it to a variable, and then put it in a loop, it'll do it for all of them. Do you see what I'm saying? That's a good way to start. Okay? So there's 10 of them. So how would you, okay, so let me ask you this. If I ask you how to, okay, I'm not trying to put you on the spot. I just did the same thing to him. If I asked you how to set the first element in that array to 0, what code would you write? What's the first element in that array? Test score sub 0, right? So do me a favor. Come in here and write test score sub 0 equals 0. Just do that. I want everybody to process this, okay? No. After the 4. Keep what you've got. So go right here, put a return, and write test score sub 0 equals 0. Does everybody agree that would set the first element to 0 first? Now, does that make sense to you that sets the first one to 0? Okay, so now what I'm going to do is I'm going to change that 0 to x, and that then is basically the equivalent of saying test sub 0 equals 0, test sub 1 equals, do you see what I'm saying? So if you can talk yourself through the 0th element, pop it into a for loop, that'll work for all. Does that help? Okay, good, thank you. Does that help? So if you're not sure, so let's go to the next one. How would you print the first, I'm not going to give it away. How would you print the first element? If I asked you what code you would use to print the first element, what would you do? Cout test score sub 0. So now if I want the whole array to be printed, change the 0 to x or index or I don't care what you change it to. Make that your for loop, and that works for the whole array. Does that make sense? You want to try, will you come, which one are you? You want to try it? You want to try printing them all? I don't want to put you on the spot. If you don't want to, just say no. Yes, Ryan? Okay. All right, so do the same thing that she just did. Come up here and just print the first test score. Here's my array. I need an S here. Will you fix that S for me? If I just wanted to print test score sub 0, okay? Okay, so now come here, return. I just want you to write the code to print the first test score. So cout what? Okay. Just to print the first test score, it's cout test score sub 0. We all know that, yes? Whatever the name of the array is, the 0th guy. Brackets, it's getting used to the syntax is tricky, okay? Put a 0 right now, just for 0, okay, semicolon. Okay, so does everybody agree that this prints the first element of that array? Now, if I want to print the whole array, let's do something different besides x this time. Change it to I. A lot of times we use I for this. Now, put this loop ahead of it, the for I equals 0, I less than 10. And now, those two lines are equivalent to cout test score sub 0, cout test score sub 1, cout test score sub 2, cout, blah, blah, blah. And it can work, I'm only doing 10, but it'll work for 1,000,000. Question? So, if I'm working on the whole array, okay, thank you. All right, so let's run this guy. So here, all right, so does everybody see what happened here? When I declare an array, what happened? 10 guys were allocated in space. And what were those guys called? Test score sub 0, test score sub. So when I did that one line, 10 spaces were allocated. And they're all blank or have garbage in it at this point. When I get to this gets set to 0. This is less than 10. So what happens first? Test score sub 0 equals 0. I need a semicolon. Can you add a semicolon? Okay. Then I bump x to 1. So 1 is less than 10, so test score sub 1. So basically, let me get a good marker. First step is space got allocated. Right here, space got allocated. And the first guy is called what? Full name, though. Test scores sub 0. That's how I refer to that first guy. The next guy is called what? Test scores sub 1. This is the element, this is the index. Blah, blah, blah. The last guy is called test scores sub 9. Okay, that's all that happened here. Now what happened here is x is 0, x is less than 10. So when I first do this first line, what happens? 0 gets put there. Then I come up and I bump x to 1. Is 1 less than 10? Yes. So test score sub 1 equals 0. So it's just all happening behind the scenes, but 10 lines of code are being executed. There's no miracle. Each one of those lines is being executed. Does that make sense? Okay? So now when I get to here, we can run this. This will actually print. It's not going to be pretty. And I could call the index whatever I want. I use I a lot. Some people use IX. So what should print? 10, 0. Now, if I want it on separate lines, I have to do it. It does what I tell it to do. It doesn't do anything, Okay? Now, this is so useful to me, I'm actually going to make this a function. So I'm going to make a function called print. I'm going to let it, it'll work for anything. Oops. And I'm going to keep using this guy. And I'm going to pass in the array. The names don't even have to match. And this can be ARR. So I can pass these arrays, and it's going to be really powerful for me to be able to do all this stuff. And so if I want to print the array, what am I going to pass it here? I'm going to say print ARR, and what am I going to pass it? What array am I trying to print? I need to prototype it. I have to do it here. Look at Java and get a little bit. Up here. That wasn't the error. It's just this. I think that might do it both. We'll see. ARR. I didn't declare. Yeah. I changed the wrong thing. I didn't need the error message. Okay, so anyway, now that array, I'm going to use it all over the place. Okay, so now I want you to write the code to input all the values. Now, what's the tip that I gave you? What's the tip, Jake? So write the code to input the first value. So what would you need to do? You need two statements. What do you need? Cout, cin, and then you need to put it, right now it'll be 0, and then pop it into a for loop. So go ahead and try it. So write the code to number 3, input all the values. So this time I'm going to ask the user to enter the array, the test scores. Who thinks they can do this? Stefano, you want to try number 3? And all these can be functions. We can work on functions more next week if that confused you. Yeah. Inside main. Yeah. That's what we started with. And this will work for any size. You know what I mean? And if I use a constant, then I don't need to put the number all throughout too. Okay, so he's going to write the code now. But can you prompt too? Add a prompt. And he needed brackets now because he has more than one line. Same rules. This is nothing new, right? We have more than one line. It has to be a compound statement, okay? Does this make sense? Does everybody have this? So now will you run this for me? And what's going to happen, it's going to do what? What's it going to do when it runs? Ask me for 10 test scores. And each one of the, so go ahead, it should run. So now it's going to ask him for 10. We could have said enter, he's going to just enter 10, any crap, 1, 2, 3. So it's going to ask for 10 test scores. He's entering them manually. If I now called print test scores, it would print whatever's in the array now. Does that make sense? So you see the power we have now with these arrays? Okay, thank you very much. All right, number 4, double all the elements in the array. So that means that I decided the test scores needed to be doubled. Ha! In your dreams. So write the code to double every test score. So what's the tip that I gave you? Try just doing the first one. Jennifer, you want to try this one? So how do you double the first one? What would you put? Test score sub 0 equals test score sub 0 times 2. Change that to an index, pop it in a for loop, and it does all of them. Does that make sense? It's all in the syntax here. We all know how to double. It's a question of where do you put the times 2, right? You're not sure if it goes inside the brackets or outside the brackets. So the syntax is funky. Okay, hold on. You're doubling. But you can save that one. Why don't you do it? Why don't you copy and paste one and put that on the next one, number 5, okay? As well. Okay, and fix the first one first. So that's +1, okay? And then you need semicolon, right? So she did 5 by mistake. Increment is you take each guy, add 1 to it. She's going to double it, which is going to take each guy and multiply it times 2, which is double, right? Don't make it harder than it is. Okay. All right. Perfect. This is 4 and 5. Is there another way that we could have done this step? Yeah. We could have said test score sub I plus plus. Make sure the plus plus is outside of the brackets. If it's inside the brackets, it'll bump I. That's something else. Okay? That'll really screw things up. All right? Okay, who thinks they can do number 6? Who thinks they can do number 6? The same tip is not exactly going to apply. But you know how to print an element, so how would you print them in reverse? Hunter, do you think you know how to do it? So what's the last element in the array? This is a little tricky. What's the last element? 9. Right? Semicolon. And then you're going to continue to go so long as you get to, no, we're starting at the 9 and going back up, but it needs to be greater than or equal, because otherwise you won't do the last. In this case, do you see why? Does that make sense? Okay. So then he's just going to print it. Does that make sense how we can print it reverse now? Does that make sense? Okay. How about number 7? Thank you very much. How about number 7? Who thinks they can do number 7? It's a little trickier, but I think we can do it. Who thinks they can do number 7? Any volunteers? I don't want to pick somebody for this if you're not ready. Who thinks they can do number 7? Sum all the values. Jillian? Okay, that's all right. But don't grab that loop. Grab the loop above, right? Yeah. I mean, we could go in reverse, but that just wouldn't. That makes sense? That's the question we started with, right? And then if I want to compute the average, can you stay up there and just finish average? So after the loop, average equals what? In this case, I know how many I'm doing, so average equals what? I or 10. Yep. That's how we started the class. Now we know, thank you. Number 9's a little trickier. We'll work on that on Tuesday. Okay? My advice, print this out blank and try it again. You know what I mean? Print it out blank. See if you can do it. I'm really stepping you through this.